All right, everybody, welcome to week one of Geography 473-673. I kind of gave a rundown of everything in the previous video, Welcome to Geography, and so now we're just going to cover everything that we're doing in week one. And so if we go down to the agenda, we can click on an introduction to R. So we're just going to get started with R, and I'm just going to run through some reasons why it's awesome, and just quickly, and then we have a downloading guide down below. So R is an open source programming language. It's the 7th most popular language in the world right now at this moment. Reasons why you should love R: speed. It's incredibly fast. It can crunch numbers so much faster than Microsoft Excel or ArcGIS. It's not even funny. It's also, on that same note, it's very light. It takes up very little room on your hard drive on your computer, whereas Microsoft Excel or ArcGIS, two really popular programs, would take up far more room. Capacity is another attribute thing that you can love a lot, and R can just handle millions of data records, and it can handle large data sets that would crash in Microsoft Excel. And ArcGIS is definitely more robust at handling bigger data sets or more dense data sets, but still R has a much higher capacity. Risk reduction. So the whole advantage of writing an R script is that if you have a specific routine that you're doing time and time again, or if you have an input data set that you can't edit, but you need to play with and then print out or save to a new data set, you can do that incredibly easily. That's what it's designed for. So the advantage of this is you don't have to overwrite data sets that you're given. Whereas, in Microsoft Excel, for example, if you're given a CSV file and you're running through it in Microsoft Excel, and let's say you have temperature in the wrong units, for example, and you need to change that. When you use Microsoft Excel, you're editing that initial file, and it's easy to overwrite that and then lose track of changes that you made. Whereas in R, you read in the file, but you're never editing that file itself. You would need to explicitly overwrite that file if you wanted to do that, and it's so much easier just to bring in that file, do what you need to do, manipulate that data as you need to, or perform the analysis that you want to, and then create the plot, create the new data set that you need without overwriting that initial data set. It reduces a lot of risk. Visualizations. R is incredibly powerful at visualizing data and visualizing big data. And so we will get into that a little bit. We won't be able to get real into the meat of it in this semester, but I cover much more advanced ways to plot in advanced R, which I offer in the spring. Collaboration. R script sharing is safe and easy. It's incredibly easy to back up your scripts, and it's free. You'll notice that what we're using right now is GitHub, and GitHub is the world's most popular coding database. Hundreds of thousands of people and coders all over the world, some professional coders who are just incredible at what they do, all host their code on GitHub, which is just a cloud, and I encourage you to do so as well. In fact, if you do install your own GitHub and back up your code on that, I will give you extra credit. Price. R is completely free. Yes, every single bit of it. This is incredible because being that it's free, you have some of the most powerful programs known to man to date in R, that it's just, compared to things like Microsoft Excel or ArcGIS that you would have to pay for, you get so much more out of R. It's so much better and faster in every single way, and I'm just a huge fan of this. The other advantage of it being free is that you don't have to be tethered into any network. You don't have to be connected into University of Delaware's VPN to be able to access these programs. You could run R, you could perform an analysis up on top of a mountain. You don't need internet. You don't need that connection. That's what's amazing about R. In the next section, we run through the downloading guide. And so there's two different things that you're going to need to download. You're going to need to download R itself, which is the programming language that we use. So you'll just want to click on this link and you'll see something like this. You want to download it for your specific operating system, and it'll bring you to a bunch of different releases of R. Some of them are just newer and have newer, not necessarily newer features, but they have less bugs. And so you just want to download the latest release. So you just want to click that. I run a Mac, so it's .pkg for me. If you run a Windows, it'll have a different extension. R is the language. RStudio is the application. And so whenever I talk about using R or running R, we will be using RStudio to use R. So it's I know it might be a little redundant at first, but I will refer to RStudio as R from time to time. RStudio is also free, and it's just the application that runs R. So essentially, R is the engine and RStudio is the vehicle. It's the car. We can drive R using RStudio. So run through another, quick example of how to download RStudio. And then after you download those two things, you're going to want to download the course data sets. And so we use a number of different data sets here. And what you can do is go to the link, go to the GitHub, my GitHub account, the course GitHub account, go to datasets, and you can download this entire folder as a zip file. And then you can just unzip it, and boom, you have all of the data that you'll need for the entire course. If you want any step-by-step examples, if this doesn't do a good enough explanation, then there's some video examples right here, installing R on various operating systems and installing RStudio. So after you download, what you'll want to do is open RStudio. So this is RStudio, this is what it looks like, and I'm just going to cover real quick what is going on here. Where you see my cursor right now, this is the script. This is the script quadrant. This is your canvas. This is where you write anything you want to write. So you can write x equals 10, or you could write message equals hello. And it doesn't matter, you can write whatever you want. Now, just because you write something doesn't mean it will run. And this is something we'll get into. So this is your blank canvas, this is what you're painting on, and whenever you want, this is where you're coding. And whenever you want to run that code or test to see if it works, you're going to run it in this console down here. So the console is where everything is run. So I typed this up here, but until I execute it down here, now it's run. So now if I print x down here, x is now 10. It's an object that we stored. And you can look up here in my global environment, which is my top right quadrant, x is equal to 10. So this just, before getting ahead, let me just explain really quickly that you don't have to explicitly type everything down here like I did in the console, x equals 10. What you can also do is you can run this code. So you can run this highlighted code using the run button, and now it ran everything that we need to. So it automatically sent all that's going on up here in the script quadrant down to the console quadrant. It ran successfully. Whenever you see a sideways caret like this and your cursor is blinking, that means that everything ran as expected. If we go up to our global environment quadrant, we can see that now message has been run. Our message is equal to hello. The bottom right quadrant right here is your file quadrant. It's also your plot quadrant. It's also your packages quadrant and your help viewer. So there's a lot going on here in this bottom right quadrant, and you can kind of toggle through each of these tabs depending on what you want to use. So this is RStudio, and this is your script. This is where you run the code. This is your environment. Whenever we're finished with the script, all we need to do is save it. So we can just say File, Save As, and you just want to save it as random.r. Every file in R will be saved every R script file will be saved with the extension .r. So we save that file, and boom, we now have random.r, which is our script up here, and this is our introduction to RStudio. This, as far as languages go, it doesn't, I've used a lot of languages. I can code in many different languages. This RStudio, which once again is what we're using here to run R, this is the best integrated development environment I have ever used. It's referred to also as IDE, and so that's that, once again, the integrated development environment. And so this is just an incredibly intuitive way to show and portray everything that you're using R for. It does a great job at just telling you, okay, this is what R knows so far. So that concludes that. And so I kind of run through what's going on here, how you can open up a new R script, and that's a good point. Whenever you open up R, it might just look like this, and so what you want to do is you want to add a new R script, and your script will pop up in the top left quadrant. So I kind of cover all that in more detail here, so run through that as you wish. Definitions and rules, I'm not going to run through these over the video. I think that it would just be kind of a waste of time, and I'm all about saving you time. So I would encourage you to run through and read these on your own. It's okay if they don't make sense right away, but they will make a lot more sense, and you will understand these a lot more as we progress and actually run through some of the tutorials. But it's just very important that you know these are here right now. So I just have some more rules and then general recommendations. I need to edit this because it's a little bit not formatted correctly, but that'll be changed. But these rules will make more sense, and I'll cover them. But then I have some general recommendations as well, and I encourage you to run through those. Now we're going to move on to the coding fundamentals. And the first is going to be entering input. So one thing I encourage you to do is to have RStudio pulled up and the book, the class tutorials, and the class book pulled up in a separate window or tab or whatever you want, and go side by side. So the first thing we're going to cover is where we write code. We kind of already did this, so if we just copy that on over and then we run that code, we have val is equal to 1. We printed that out. Val is 1. Now, notice what I did here. Previously, I had written x equals 10, and now I just wrote val is equal to 1. This is referred to as the assignment operator. You can use sideways, caret, dash, or equals to assign an object. Val and x are both objects right now. And because they're objects and because I ran them and told R, okay, val is equal to 1, x is equal to 10, I can find these over in my global environment. Traditional R programming uses the sideways caret dash. I use the equal sign. So you might see me bounce around and use both, but you can just use the equal sign. That is completely fine. So this is where you enter everything, and remember, after you type it all up and you code up here, where you want to run and test it is down here. If I didn't have something for after I declare I'm using the assignment operator, if I run that line, this plus sign will show up right down here. And that is saying that if I hit enter, 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 it still has the plus sign. That is telling me that I need to add something there because I'm missing something. So I have val equal to 1, and now put the 1 in, and now I have the sideways caret down here in the console again, telling me that I successfully went through and declared that as an object, declared val to be equal to 1. So now I can print val, and val is returned as 1. So that is what's going on there. The next thing that I wanted to talk about is running code. You might have seen me real quick. If I have val equal to 1, I can run this using the run button up there, or you can also use the keyboard shortcut. If you're using Windows, it's Control and Enter. If you're using Mac, it's Command and Enter, and you can highlight what you want and hit Command Enter or Control Enter, and it will send it down to the console and run that code. Alternatively, you can just have your cursor at the end of a line, Command Enter, and it just ran that one line right there. Evaluation. So you might have seen me do this. You might have already noticed this already, but if I just get rid of everything here, I just say val is equal to 100. And now if I want to run this code, I hit Control Enter, or Command Enter, and you'll see that it's down here. If I want to print this value out, what I can say is print val. This is called explicit printing, or I can just do auto print, which is just query the variable. So if I run this line, print val 100 spits out, or I can just run val 100 prints out. So what's going on here? Explicit, and then this is auto, and it's just easier to use auto there. Can do the same thing with sequences. So if I have a sequence called mySequence or mySeq, and I run it, whatever object that you have down here, mySeq, 10, 11, all the way through 20, and I notice that it's over here in my global environment as well. So remember, whenever you see that sideways caret down in your console, you're good to go. So now, notice that what happens when I do this. If I add an extra colon right here, which, by the way, the colon is how we go ahead and query a sequence of numbers, so I can do 10 to 29. Run it and print out mySeq, and now we see that our sequence runs to 29, so colon is the sequence operator. But notice what happens if I add a random extra colon. Still has that plus sign, so it needs something to do. We need something to go in there. And let's say, for example, I type something random B. Error. Object is not found. So whenever you receive an error, don't get discouraged. Just try. You're going to experience a lot of errors in your code. I still experience a lot of errors. It happens. So, but pay attention to the errors, because they can actually tell you a great deal. So they're actually pretty good at explaining what's going on, and the reason here is that object B is not found. So B does not exist anywhere. R does not know what B means. So if errors pop up, just don't get discouraged. The next thing that I want to cover is R objects. And so there's basic objects, characters, numbers or numeric, integers, complex numbers, and logicals. I'll let you read through those at your own leisure, but I'll just run through here creating vectors. And so what I have here is, if I run this, x is going to be a numeric, so I print x, and so it's exactly what we listed it as up here. And with a logical, which is a true or false, notice that it's all caps. We have true and false. Same thing, you can use this as the shortcut for the logicals, T and F. I recommend just using the long form. It just makes a little bit more sense. Characters, which is any text, any strings, and you'll notice that it's a string or a character because it has quotations around it. Integers, so just like we kind of covered before, we can run a sequence of integers, and then complex numbers, which you might use from time to time. You can store those in R as well. So these are the basic atomic classes within R. Notice here I have this C before a parenthesis. C right here is concatenate. Concatenate is a fancy word for combine. So this says I want to combine 1.25 and 2.50. And I separate what I want to combine via a comma, and I surround what I want to combine in parentheses. Everything in R comes in pairs. If you use this is one of the rules, if you use parentheses, quotations, brackets, curly brackets, they must be used in pairs. They must have an open parenthesis and a closed parenthesis. So right here, if I run this line down here, x is equal to concatenated 1.25 and 2.5. This is the same as running this line right here, concatenate 1.25 and 2.5. So it's a concatenate is a super useful function. It allows you to just combine things together, and it's just it's a special function because it's C. You can mix objects together, and this can create some headaches. So if I have these different things right down here, if I run those, y is equal to a and true, and if we run, notice that it automatically put quotation marks around true. True is illogical. Notice that it's a different color up here and that there's no quotations around it. We are saying that it's illogical right there. So if I say y equals true and I print y out, notice how there's no quotations around here. So this is what happens when you mix different atomic classes together. It automatically converts them to the same atomic class, because anything within a vector, which we'll cover vectors in a little bit more detail, or you can read through them on your own. Whenever we have a vector, we cannot combine things of different atomic classes. It will automatically go to the easiest atomic class it can transfer things to. So it's easier to make true a string than it is to make a logical. Explicit coercion, and what coercion means is we kind of reference it right here, and we want to transform things. So coercion is really just about transforming it to what you want. So let's say, for example, that we have message equal to, let's just do, the message is going to be 12. And notice that message, if I print it out, it's 12, it's a character, it has quotation marks around it. I can use the class function on message, which is my object, and it will return a character. So it's just character class, it's a string of characters. I can convert this or coerce this. Coercion is just another fancy word for convert. I can convert this to a numeric by using this following function, as numeric of the object message. So if I run it as numeric, I can convert it from a character class to a numeric class. We'll cover these functions in more depth later. You'll get used to them as they go along too, so please don't be discouraged. I'm just running through this now and kind of getting you more familiar with R. So this kind of goes through how you could convert into some different examples, and I encourage you to go through these on your own. Matrices. So matrices are just two-dimensional or multi-dimensional vectors. They're also a two-dimensional matrix is an array, and we will deal with arrays very frequently here. So for example, we can have spatial arrays of longitude, latitude. So if I come down here and I write M matrix, I run that code, and then I print M down here. It's a blank matrix, so it's filled with NA, or not available, but we notice that we have 2 rows, 3 columns, just like we told the matrix function to give us. So you can create matrices, and you can get attributes or dimensions of these matrices using the dim or the attributes function. So you can do quite a lot here. You can fill the matrix, so we only need to specify row and column, but we can fill it. So the matrix function here, we can just provide it with the data 1 through 6. And why did we choose that? Because 2 rows, 3 columns equals 6 cells, and we can fill that using 1 through 6. So now if I print M again, we have 1, 2, 3, 4, 5, 6. Notice how in R everything is stored row, comma, column. This is incredibly important and just something you have to get used to. And so it's always going to be row, comma, column. So, and also notice that over here we have my M matrix, which I declared over here, and notice that it gives me the option to click on it. I can click on it and it will pop up, just give you kind of an example of what it would look like if this data was in Excel. And when you click on your data up here, it's running this function for you down here called M. Real quick, when I refer to things as function, the way that we know that it's a function is because it's followed immediately by parentheses. So if again, we use the matrix function just there, so I run matrix, and you'll see that RStudio is incredibly helpful because if you type something, it will automatically give you options if you stop typing. So if I type mat and then stop typing, it will give me different options for different things that I can autocomplete with. And if I want to use matrix, it will give me, here's what matrix is, here's this function. You give it data, number of rows, number of columns, and then some different arguments within these functions. So this is another key thing. So functions, we know that it's a function because when I hit tab, which is a shortcut keyboard function, it will auto-complete. So if we have matrix out here, I'm hovered over matrix, and that's what I want to use, hit tab, it automatically pops up these parentheses for you. That's how we know this is a function. Arguments go into the function. In order to run the function, you need to provide it with arguments. So one way to think about it is function is your airplane, and each argument is fuel or oil or whatever the different components are going to be within that airplane. So again, if I can use my handy tab function, it will give me options for what can go inside of this matrix. So we have data. So if we say data, okay, I want 1 through 6. Tab again. Data doesn't pop up anymore because it's already been filled. N row. Number 2, and call 3, run that, boom. That's what it's looking like down here. Now notice that I did not declare M as a matrix. So if we make a new matrix called mat, copy this. Now mat is an object that exists in my global environment. So now whenever I call on mat, R knows what I'm talking about, and it can return that to me. Another key thing is that just because I run something down here does not mean it will pop up in the script. If this is something that I want to save to my script, I need to have it up in my script area up here. You can run whatever you want down in the console. The console is really where you're testing things out. It's where you're executing the code. You know, you can write whatever you want down here and it will pop up in your global environment, but a good practice is to write everything in your script and run it down in your console. Now, let's say, for example, that I needed a little bit more help with my matrix function. There's an automatic help function. I can do help matrix, and it will pop up with descriptions, how to use it, what the arguments are within this function, and more details, even some examples. All of this can be done without internet. This automatically comes downloaded within R or whenever you install packages, and we'll touch on that a little bit later. Lists are a special type of vector in R, and so earlier we talked about how whenever you, up here, whenever you combine or concatenate things of mixed types, it will automatically convert things to whatever type is easiest. If we come down here and we combine a list, so now notice we're using the list function instead of concatenate. So we want to throw all of these different things into a list. We run that and we print out X down here. Everything held its class. So we notice how it didn't just convert everything to a character or a logical or a numeric. So lists are special in that regard. and we run through these. Factors are a special type of categorical data that can be ordered or unordered, and I encourage you to run through these. They're just kind of, it's a nice way of label or just keeping track of the different levels of your data, and I encourage you to run through that on your own. Missing values we kind of touch on, and so that's, NA, not a number. So if I say x equals NA down here, print x equals NA, and then I can use the is.NA function on x and say, is this NA? True. Yes, it's true. X is NA. Data frames is basically an Excel spreadsheet. Data frame is what we're going to be working a lot with, and so I can copy this data frame on over. X is equal to this data frame. Notice that it pops up here, my data, and again, I can click on it, and this is what it looks like. So it kind of mimics an Excel spreadsheet, but you can just do so much with data frames. We'll be working extensively with data frames, so there's something to get used to. So you can combine lists in data frames, and you can provide things with variables with values associated with those variables, and those variables or columns in this case can have names. So you can run call names function on our X data frame, and we have foo and bar, which are our column names here. Additionally, we can just run names on X, and it will print out the column names automatically for us. So those are the names of the variables or the columns in this data frame. So I encourage you to run through that, and yeah, so that kind of concludes. I ran through that a little bit quickly because I just wanted to kind of cover that and show you, but please read through that in detail. At this point, the last thing that I will run through before I just turn it over and encourage you to double back, go through this step by step on your own, is we're going to cover some basic scripts here. The first thing that we're going to cover is global carbon dioxide concentrations. So this is just an example script of, okay, we have this data set of carbon dioxide, and we want to plot it. We want to plot it up, and we're going to hope to plot this plot right here. So we're going to run through it line by line. So first thing is, go back to our script. Let's clear everything out because we don't want to save that. And let's put a new script up. So I forgot to mention this earlier, but I wrote it. It's in the manual here. The pound key is your comment. Comments in R, you can run whatever you want. You can type whatever you want. It's just a note. It's just a note that you want to have in R. So carbon dioxide script. And you can run that line and nothing will run because it's commented out. So if I have x equal to 10, I can run that line, and now x up here is equal to 10. I can print that out. But if I say x equals true, and I put a comment in front of that, anything after one comment on that line will not run. But if I have something on the next line, y equals false, it will run y and it won't run x. And see, even though it printed it down here, if we go up here, x is still equal to 10. So, and to just make that a little bit more explicit, if I have x equals 10 and then I overwrite x to be true, and then have y equal to false, and I run those three lines, it'll print it down here, but it won't run it. X is still equal to 10. If I remove this comment, I will overwrite x, and x will be true. Back to the carbon dioxide script. So there are pre-built data sets into R, and the one we're going to be using here is CO2. So if we type CO2, an automatic autocomplete pops up CO2, atmospheric concentration of carbon dioxide expressed parts per million. So we load that in, control enter to run that line, and this is what the preloaded data sets look like. So this is a monthly data set of global carbon dioxide concentrations from 1959 to 97. So this is exactly what we're doing here. We print out the data, and let's just, for the sake of everything, let's load in CO2 data and let's load in the CO2 and save it as an object called CO2 data. Run that line, and now up here, we have a new value, CO2 data, time series. And so we print it out, and it's the same thing as our CO2. So we just gave it a name, and now it's an object in our environment. We can run the class function to say, hey, what's going on here? What class is the data? Class is TS, which is short for time series. And one thing that I've wanted that I should always recommend and is really good practice is to comment out your code. And you remember that each comment you make is taking notes. Not only is it preventing everything from after a comment being run, but it's also a great way to just keep track of what's going on with your code. So load the data set. That's what we're doing up there. And then I want to comment this line and say, okay, rename the CO2 as CO2 data. Find the class of CO2 data. Now we want to run a summary of the CO2 data. Say, okay, what are the stats looking like? So we can go, boom, there's the summary. And so we give just some quick statistics, minimum, median, mean, max. And so these are max concentrations within the data. So summary is a great function. And remember, how do we know it's a function? These parentheses right here. And CO2 data is an argument of the summary function. How long, how many months is the CO2 data? We run the length function on CO2 data. It's 468 months, so that's all good. And then can we plot this data set? So we are going to plot using the plot function. And the plot function takes a couple arguments, and it can take an x argument, a y argument, and in this case, because it's a time series, it automatically will assume that we want the y to be the y-axis here to be the values, and the x-axis to be the CO2 values, and the y-axis to be the concentration, and then time on the x. Now, we also have some different arguments in this plotting function, ylab or ylabel, and which we want to be equal to atmospheric concentration of CO2, and then main, which is the title argument. So what we can do is we can go ahead and we can run, if we're ever confused about this or need any hands or any ideas on how this works, we can run a help on plot. Remember, tab is your friend, and it will kind of give us an idea of what's going on. So main, an overall title for the plot. So this is an argument here. So I can run this, and then boom, the plot automatically pops up, and this is global atmospheric concentration of carbon dioxide from 1959 to 97. You wrote your first R script, so congratulations. We will now save this, and so we can just save this file as co2.r, hit enter and save, and now what we can do, we can just close this. If I want to open that file back up, just go to open file, co2.r, and I can rerun this entire script and it will come up again. And so, for example, if I can clear out all of my plots using the sweeper button over here, and I can run all of this data, boom, the plot comes back. I run through another example of cars, Motor Trends magazine data, and it just runs through another example similar to that where we make a plot and then gives you the entire script of what it looks like all together. And I encourage you to run through this on your own. So this concludes week one, and please remember that I kind of flew through this, and I did so on purpose because I can cover things quickly and show you how to do things. But I think that where you'll really get the most out of this is just going through these tutorials and this manual that I've created yourself, and just kind of reading through it and going through the examples. So that concludes everything that I expect you to be caught up on week 1, and next week we will start with scientific R scripts, and we'll kind of get into some more nitty-gritty scientific specific R coding practices.